In this lesson, we're going to look at discrete data. We already looked at continuous data. And our essential question is, how do you identify discrete data from a verbal description or a graph? So again, we're looking at specific values and characteristics that are going to identify this. So just a reminder, domain is the set of all the x values, range is the set of all the y values. Now in some cases, discrete data is actually a little bit easier. Okay, discrete data is data that cannot be any value. It cannot be measured at any point. So like for example, if we were comparing number of tickets to their cost. You can't buy part of a ticket. You can only buy 1 ticket, 2 ticket, 3 ticket, 4 ticket. And so the number of tickets cannot be measured at 1.5. So it has to be specific values. Now it doesn't mean that it has to be a whole number or an integer. You could still have decimals, but it can't be measured just at any number. The domain and range for discrete data is always written as isolated numbers. It is a list. And so here's an example of a domain that I might write. This means x such that x is equal to each of those numbers. Or that line means y such that it is equal to all of those numbers. Okay? Okay, so here is some verbal examples. The function, blah, 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 represents your monthly rent, y, in dollars when you pay x days late. Well, we actually talked about this one yesterday. If we're talking about the number of days, and, you know, if I were to count an assignment late for you, Canvas might do it, but I wouldn't say it's 1.5 days late. It's just 1 day late, 2 days late, 3 days late. And so because we're not measuring at any number, we're measuring at very specific numbers, this would be considered discrete. Okay, number 2, the function a equals negative 4b plus 14 represents the number of a of avocados you have left after making B batches of guacamole. Now, I know that we can take recipes and we can half them, but do we take a recipe and make 1.346 batches of them? No, we do not. So because we can't have any number of batches. And when I say any number, you should be imagining that really weird number. So because we can't have any number of batches, because it has to be specific, this is discrete. Okay, the last example. It says a baseball team's rank depends on the number of games the team wins. Well, if we are comparing a baseball team rank, if you know what a rank is, that means you're in first place, second place, third place. That is your independent variable. Do we rank people at 1.5 or 2.5 or 3.5? And the answer is no. Okay, we rank them at very specific numbers. First, second, third. And so because of that, this is another example of discrete. Okay, so here are some graphs now. I want you to notice that these are specifically scatter plots. So discrete graphs are going to be isolated points. They're isolated points. There's no line on here like there is with discrete data. I mean with continuous data, sorry. Okay, and so this is very, very simple. To list the domain, all we have to do is list the x value of each point. And I'm going to do it in brackets. I'm going to do the x such that. So I'm going to go to my point furthest on the left, and we've got x is negative 3. We've got x is negative 2. X is 1. X is 2. X is 5. So all I did, very simple, listed the x value for each coordinate. Okay, so then for the range, we're going to do the same thing, except for now we're dealing with y. Okay, so I'm going, really we should go from the highest or the lowest to the highest, so now we're kind of switching it up. But if it was in a different order, it wouldn't be wrong either. So here's my lowest point. That is at negative 5. And then this point, my y value is 0. Oh, look, I have 2 points with a y value of 1, and then a point of 4. Notice I'm not listing that 1 twice. Okay, and then in the next one, okay, again, we're going to list the domain. We're going to list the x values. We're going to start with the lowest, the smallest, so the point furthest to the left. The x value is negative 3. And then I have 1. And then I have 4. And then I have 5. I'm just listing the x value for each point. And now I have my range. So I'm going to go to my lowest point, which is at negative 4. So y such that it's negative 4. It's 0. It's 1. And again, I have 2 that are at 1. And then it is at 5. And there is my range. Simple as that.